Hello guys, welcome to our YouTube channel CIT Innovation, where innovation means imagination. Today I will demonstrate a new project that is Magneto lock, secure and automatic train coupling. As we know, train coupling is a crucial process in railway industries. Traditional railway coupling mechanism uses manual mechanism. There we need levers. It enables multiple railway cars and locomotives to connect and disconnect and operate as a single unit. As we know, traditional coupling mechanism is a crucial process. In this process, there is inefficient and safety risks. So to prevent this type of risks and issues, we introduce a project that is electromagnetic coupling mechanism process, in which we use the electromagnet through which whole the coupling process is done. It is efficient and it provides safety, and the operation is be secure. The primary objective of this project is increased automation, time efficient, enhanced safety, secure and reliable connection, and remoteless connection. Now I have to introduce the hardware components which I have used. Basically, I have used core components. Here we used electromagnet. It is the electromagnet. It is the metal coupler. And we use the locking mechanism. We use servo controller with servo motor. I explain the control power system. Here we use microcontroller as a Arduino Uno that controls the coupling and decoupling process, and it is the power supply which I have used this power supply unit through SMPS. This provides a electromagnets and control power system power. Now I explain the sensors communication. First, proximity sensor, ultrasonic sensor. It is the ultrasonic sensor, detects the distance between train units and trigger the coupling process. As we know, in the practical process, the distance between the locomotive and the bogies should be 20 cm, but the project purpose we have only used 6 cm. Now I have to explain about the Hall sensor effect. Now the second sensor is Hall effect sensor that detects the presence of magnetic field of precise alignment. Here, when we on the power on the magnetic field, then the Hall sensor detect the magnetic field is generated or not. Now I will start to demonstrate about the working principle of this project. Here, the first operation is train move forward. Second operation, train move backward. Now I explain the total operation of this control unit. Here, this is the voltmeter that detects how much amount of voltage is required to operate the motor. It is now 9.15. When motor moves forward or backward, according to this, the voltage is fluctuated. Here, it is the all lights that we have used for decoration purpose. Now I have to introduce about the magnetic field. Here now the magnetic field is on. It takes 10.9 voltage and it detects 3.07 ampere, and the Hall sensor that detects that the magnetic field is generated or not. For the manual mechanism process, we also have used servo motor that is controlled by servo controller. It is the servo controller through which the whole coupling process is mechanically done. Here we have used cooling fan. As we know, whole the power supply is supplied through DC supply, so there is produces heat losses. So we have, for the cooling purpose, we use the fan that cools down the total coupling process. Here also we have detect about the short circuit detector that also detects that the whole coupling process is done or not. As the coupling process is done, so the green light is indicated. Now I have discussed about the IR sensor. Now in the red light is blinking. When any object is come forward about the 10, the green light is indicated. Now I have let's discuss about the IR sensor which I have used here. When any object is come forward this, the red light is indicated, and there in the control box also the green light is also indicated, blinking not. That means any object is in front of the train or not. Now I explain the main working principle of this project. For the project purpose, the distance between the locomotive and the bogies is 6 cm. When the locomotive and the distance between the bogies is 6 cm, the buzzer sound is beeps that detects the distance between the locomotive and the bogies is 6 cm. Now it is ready for the coupling process. Now the magnetic field is on. The total magneto log here, the total mechanism is process is done here. Now we, for the safety purpose, we also use the mechanical coupling mechanism through the servo controller. Move the servo controller, it also detects that the total coupling process is done. This is all about this project. Thank you.